This is paper 1, video 4 for the February mock. First topic we're looking at here is all to do with areas of circles. As it says up at the top, it's wanting these in terms of pi. So it's given us some extra information instead of us giving us information about the circle itself. So for the first question, it says one side of the square is 10 centimetres. So if I put that information on, it says that this here is 10 centimetres. If you remember, to work out area of a circle, we need to use pi r squared. So if the full length of this square is 10 centimetres, that means the diameter of this circle is 10, so the radius would have to be half of that, so 5. So for this first circle inside the square, should I say, we would do pi times 5 squared, so pi times 25, which we would write as 25 pi. For the second question, it says that the perimeter of the square is 32. Well, the perimeter is the distance all the way around the edge of the square, so if that's 32, each side is the same length, so we would have to do 32 divided by 4 to give us 8 centimetres, so that means each side is 8. So if the side is 8, the radius again would have to be half of that, so 4 centimetres. So we would have to do pi times 4 squared, which is pi times 16, and we would write that as 16 pi. For the third question, it says that the area of the square is 16 metres squared. So to work out area of a square, we would do length times width, but because the sides are the same length with it being square, what number times by itself makes 16? Well, that would mean each side of the square would have to be 4 metres. If the full length is 4, the radius is half of that, remember, so 2 metres. So we would do pi times 2 squared, which would be pi times 4, which we would write as 4 pi. Next one down, area of this square is 4 millimetres squared. So using the same idea as above, what number times by itself would make 4? Well, that would mean each side here would have to be 2. So if that side there was 2 millimetres, that's the same as the diameter, so the radius is just 1 millimetre. Using the area equals pi r squared formula again, that would mean pi times 1 squared. 1 squared is just 1, remember, so pi times 1, which would actually just be written as pi. The next topic we've got is writing numbers into standard form. Now there's quite a lot of questions here, so I'm just going to pick out a couple so you can have some practice yourself. So the first one, the initial part of the number in standard form must be between 1 and 9.9 recurring, so I'm just going to use the first bit of the number here and put 4.3. Standard form is always times 10 to the power of something. Well, how many times would I need to multiply 4.3 by 10 to make it into 430,000? I'd have to times it 5 times. You can cheat and do a quick little count up to speed up the process. Remember, for large numbers, it's how many numbers are there after the first one. So in this case 5, so to the power of 5. For a smaller number, so this one, 0.00039, the first number, or first part of the number, must again be between 1 and 9.9 recurring. It is always multiplied by 10, but if we were to multiply this by 10, it would get bigger. That therefore shows that it would be a negative power. Putting a negative power on here would actually mean the same as dividing by 10. So how many times would I divide this by 10 to get back to the original number? It would have to be 5 times. Your cheat quick way of working this one out, if you're not too happy with that, is simply to count how many zeros at the start. The next topic is solving, but this time not equations, inequalities. To solve an inequality, we treat it exactly the same as an equation. So if it makes you feel happier, you can write the question as 5x equals 15 to start off with to help you think about it, as long as in your final answer you put the inequality back in. So here I'd have to divide both sides by 5 to give x is 3. So for the inequality, it'd be x is less than 3. Divide by 7 for this one to give us y on our own, so y is greater than. Minus 21 divided by 7 would give us minus 3. The only ones to watch out for are these. When you are going to have to divide by a negative number, that flips the direction of the inequality. So here, if I were to divide both sides by minus 4, that would give me b. 16 divided by minus 4 is in fact minus 4 as well. And because I've divided by that negative, the inequality now goes in the opposite direction. Same for this next one. I would have to divide by minus 9. So I'm going to get x, flip the sign. 81 divided by minus 9 would give us minus 9. Here we're just dividing by a normal positive number. So if I divide it by 8, gives us a less than, no need to change that. 20 divided by 8 doesn't go perfectly, so I'd probably write that as 20 over 8. And then I'm going to simplify this, so it would give me that a is less than. Dividing top and bottom by 4 here gives me 5 over 2. You could also write a is less than 2.5, but either answer would be acceptable. Same thing for the next step, but again look, we're dividing by a negative number. So that will give me n. 22 divided by minus 4, that's minus 22 over 4. And we flip the sign because we've divided by a negative. Now I'd simplify this to give me n is less than is minus 11 over 2. For the next set of inequalities, we have got numbers on either side of the algebraic expression. We still do the exact same thing. So if I divide by 2 to get x, I would have to divide both numbers by 2 as well. 2 divided by 2 is 1. 10 divided by 2 is 5. Because it was just a normal positive 2, no need to change the signs. For this one, to get x on its own, I would have to divide this by 3. So I'd do the same to either side, and the signs would not have to change because I've just divided by a normal 3. For the one at the bottom though, I'm going to have to divide by negative 4. 20 divided by minus 4 would give me minus 5. 44 divided by minus 4 will give me minus 11, and I would have to change both sides because I've divided by minus 4, a negative number, to give me this.